Okay, Shabab. So like I said, today we start with technological hazards. And by the way, technological hazards, you can also call it man-made hazards. You can call it human-made hazards. All right. And this could occur as a result of technological innovations today in the environment and the world, as well as human development. As we continue to grow, we continue to innovate and bring in new technology into our environment. This may come with also new hazards. All right. You could remember not too long ago, we had the bombings from the phones, from the Samsung phones. You remember when they were they were exploding. So this is an example of a technological hazard. So most technological hazards may occur in the transportation sector, all right? May occur in the infrastructure, in the industry, as well as in buildings and structures. We may have technological hazards occurring in those areas. So the first one we're going to talk about is what we call structural fires. Structural fires can start or can be triggered or exacerbated, which means increased by natural processes such as lightning, high winds, earthquakes, especially earthquakes. We have what we call post-earthquake fires, which occurs when you have lines, gas lines being broken because of earthquakes, during earthquakes. You could have volcanoes, you could have floods also leading to fires, and human or by human origins. And this could be arson, when somebody goes and burns the building, or accidents, carelessness, and things like that. So lighting is the most significant natural contributor to fires affecting the built environment. Buildings with rooftop storage tanks for flammable liquids are particularly susceptible, and they are particularly vulnerable, especially when you have industrial buildings and you have flammable materials at high elevations. According to GDC in Saudi Arabia, that's General Directorate of Civil Defense, the last statistics, which I think is as far back as 2012, all right, 1434 AH, was at 45,928 fire accidents, causing 238 civilian deaths, 1,799 civilian injuries, and about 212 million Saudi riyals in material losses. And it is estimated that approximately 65% of fire accidents occurred in residential buildings. Now, one of the reasons why it's happening in mostly residential buildings is because of the lack of access to fire safety provisions, which are usually not provided mostly in residential buildings, unlike industrial facilities. Also, most people in the residential buildings are usually not trained or experienced in how to combat the fire when it starts, as well as some of those buildings are old buildings, okay, and they might have faulty electrical connections, and all this may lead to fire. Now, this one shows an example of a tower fire that occurred in London, in the Grenfell Tower, which became a really big issue, and that I'm not sure if it's resolved today. A lot of people lost their lives in this building fire. Aside fires, we could also have blasts, okay, which is bomb blasts. When due to terrorist activities, some people may drive a huge tank full of explosives and set it off close to buildings. Okay, this is the famous Cobalt Towers bombing in Saudi Arabia. I think this was probably in 1995 or something like that. All right, so you could see the whole facade of the building has been cut off and damaged. Okay, so this is an example of technological fire hazards coming from fires and coming from bombings. You could also have dam failures. Okay, dams usually are constructed for many purposes, especially flood control and irrigation. Basically, a dam is used to dam up water or store up water for use, usually to irrigate farms and sometimes also to control floods. So dams most often fail as a result of maintenance neglect. Okay, usually dam will fail and will lead to spill, right? Or overtopping the dam, or the dam may completely fail and release all the water, leading to flooding of the the entire area. So maintenance neglect or poor design, okay, overtopping of the dam when you have the water being stored is above the capacity of the dam, or structural damage, which may also be related to maintenance neglect. Structural damage may also be caused by earthquakes, collisions, or blasts as well. So dams are both publicly and privately owned and maintained. So their monitoring can pose a challenge to offices of emergency management charged with assessing associated hazard risk. In the United States, the United States boasts of about is the second greatest number of dams nationwide, as exceeded only by China. They have a lot of dams. This is an example of a dam here in Saudi Arabia. It's called King Fahd Dam in Bisha. Now you can see here that it stores up a huge quantity of water. And if there were a failure of this dam, or the dam were to be overtopped, you could imagine how this dam will flood the area downstream, that is towards this area. Okay, you can, if there's a village in that area, or there's any facility in that area, or any important thing in that area, you could imagine how the dam will lead to the flooding and destruction of things towards that area. Here you can see the failure of the Oroville Dam in California, United States. Okay, so you can see this here where the water flows out. This is a huge, by the way, it's a huge outlet, and it started to fail gradually. The concrete started to fail gradually, and they started to expand. And because water keeps flowing, it keeps eroding the concrete. Once the concrete totally gave way, the water started to erode the laterites. All right, and this led to all the water being released and then flooding of the entire area. All right, this is one of the technological. I think this happened a long time ago, also in the United States. Also, you could have hazardous materials incidents when you have release of hazardous materials into the environment. Okay, so this could be chemical substances that, if they're released, they pose a threat to environment or personal health. Hazardous materials may be explosives, it could be flammable, it could be corrosive, poisonous, radioactive, it could be toxic, or any other kind of danger that this kind of materials may pose to humans and the environment in general. So release can typically occur during transportation. Okay, there could be accidents or accidental releases at production, storage facilities, where these materials are being held, where it is being stored, is being transported. All these releases, accidental releases, could lead to hazardous incidents. Now, depending on the nature of the chemical, results of a spill or release can include death. Okay, it could lead to fatalities, serious fatalities. It could lead to injury, long-lasting health effects. Okay, especially when you have radioactive materials and things like that. Damage to buildings, homes, and other property. So it includes a lot of damage, not only life. Okay, not only life, but also property, and of course the environment ultimately. So you can see here, this is an example of a hazardous cleaning site. Usually you could study this under OSHA in the HAZWOPER, hazardous waste operations, as OSHA was how we call the HAZWOPER. So basically you can study what are the procedures used in cleaning up a hazardous material site. This is a washing station where you can see that they're trying to wash this guy, the materials off from his body. Okay, I can see they have to use full body protection, right, when going into a hazardous contaminated site. Also, you can have what you call nuclear accidents, okay, especially with the drive for alternative energy in the world today. We have nuclear accidents, or if you have nuclear energy as an alternative, then you have to be careful about nuclear accidents and ensure safety. Now, though radioactive materials have many benefits, of course, including generation of power, scientific treatments and experiments, new detection, imaging technologies, etc., the radiation emitted from these materials can cause immediate and lasting tissue damage to humans and animals upon exposure. Now, these materials must be handled and contained using specialized techniques, materials, and facilities. Exposure to radiation can be the result of an accidental or intentional cause spill, as an accidental release or intentional release, breach of the containment vessel when you have loss of containment, okay, escape of gases, or an explosion. Now, one of the worst nuclear accidents to date is that of a reactor core meltdown in Chernobyl nuclear power plant in Ukraine. And this is on April 26, 1986. All right. So you have technological hazard, Chernobyl nuclear power plant in Ukraine. You can see here, Jihadists traveled as far as neighboring Belarus. Over 336,000 people had to be evacuated and permanently resettled. After 20 years, the area is still uninhabitable, as you can see. After 20 years, still people can't live here. Okay. Another one accident is that which happened in Japan, in Fukushima nuclear disaster. Right? And next, you have what we call terrorism, like the picture I showed you earlier on of the blast in Khobar. So this is the use of force or violence against individuals or property for purposes of intimidation, coercion, or spreading fear in order to attain political, religious, or ideological goals. Okay, so terrorism can be in different forms. And the primary method by which governments manage the terrorist threat is through both covert and overt intelligence. Covert means that they keep watching the people openly at the airports, security checks and all that. And overt means openly, and covert means what? Hidden. They have some investigation and intelligence gathering and all that. So monitoring methods have expanded greatly with the advent of surveillance technologies. Okay, statutory authorities have been expanded to allow for monitoring of phone calls, bank transactions, and other activities, even though this is still relatively still controversial because of some groups that oppose this level of control. Next, we have what we call the CBRN, or it's called chemical, biological, radioactive, and nuclear. And these are usually weapons, okay, that have potential to bring about an extraordinary degree of death, injuries, and property destructions. Mostly used by countries in war, though as different governments are trying to control this. Several names have been given to this group of weapons, including WMDs, weapons of mass destruction, NBC weapons, that's nuclear, biological, and chemical, ABC, atomic, biological, and chemical weapons. But usually you can just use CBRN, which is chemical, biological, radiological, and nuclear. This covers everything. Now, in the case of official government possessing CBRN, mitigation is generally performed through the use of diplomacy, okay, because even once one government has it, then other countries try to be diplomatic. They try to have international agreements or sanctions for some countries that might not want to comply. As for groups, like terrorist groups or different groups of people, then the control is usually performed through raw materials regulation and monitoring. They ensure that people don't get access to the raw materials that can be used to make this type of weapons. We have surveillance, other intelligence gathering, and even at times military action, okay, by arresting some people that are trying to obtain those materials and things like that, okay? So ultimately, once you know that we have natural, okay, hazards, okay, as we discussed previously, and also technological hazards as well, the ultimate step is to carry out a hazard risk management. How do you manage the risk of this hazard? So firstly, you have to identify the hazards, okay? Firstly, you identify the hazard. Identifying the hazard is that you have to know which of those hazards are most likely to occur in your own community, in your country, right, or your community. First of all, identify them. Once you identify them, you assess the risks for each hazard identified. So you analyze the risk in relation to one another in terms that you determine what are the consequences of those hazards, okay? And as well as the severity, the consequence as well as the likelihood of its occurrence. What's the chance or the probability that this will happen? Okay. Once you do that, you can analyze the hazard risk in relation to one another. You prioritize them and treat the risk according to prioritization. Okay. Treat the most, because usually what happens, especially for this high level of hazard, is that there's lack of resources for you to deal with all the hazards on the same level and at the same time. So you have to prioritize them and know which the most likely ones should be dealt with first, and the ones which have the highest consequences as well. And there may be other considerations in determining the priorities. Now, hazard identification is a process through which all hazards that have or could affect an area of focus are identified and described. This is the first step, okay? Hazard identification. This is done through a number of methods, including historical study. You could look at the history of your country in the last 100, 200 years and see what are the historical events naturally occurring or technological occurring, especially for technological hazards, especially in the last 20, 30 to 50 years. We could also brainstorm depending on the and the information, scientific information available and knowledge available on the geography of that area. We can carry out some scientific analysis, subject matter expertise, contact some experts that have subject matter expertise on various areas, and can derive information from them to know what are those hazards and what are the characteristics of those hazards that may be occurring in that geographical location. Next is we carry out hazard risk assessment, which is the process through which the threats posed by each identified hazard is investigated. We calculate the risk based on what the hazard likelihood and the hazard consequence, as I said. And risk assessment approaches range from qualitative to quantitative, as well as several computer-based models for natural hazard risk assessment, okay? So you could have quantitative risk assessment, you could have qualitative risk assessment, you could also have computer-based models for natural hazard risk assessment, for example, flood risk assessment, seismic risk assessment, okay, and all that. Now, the value of the risk analysis process in prioritizing risk is significantly improved with supplemental methodologies. Now, you could improve the risk assessment analysis by having what you call vulnerability analysis as well. Vulnerability analysis simply refers to the level of vulnerability of that community, okay, or of that focal area. How vulnerable are they to risks and to hazards? Once you know this, you can incorporate this into your risk assessment and the results could be more robust. So you could look at issues like social vulnerability, environmental vulnerability, physical vulnerability, and economic vulnerability. So these are various examples of how weak a community can be at in face of these hazards or these risks. So risk can also be prioritized according to the acceptability of the population at risk. Sometimes some populations refuse to accept the risks that are in their community, right? And because of that, they might ignore it or neglect it, making it a big problem. Next is that we have what we call social economic risk factors that may need to be considered as well. So it has long been recognized that a strong correlation exists between disasters and poverty. Okay, I'm probably going to discuss this in more details in some later lectures. Okay, so disasters and poverty is that sometimes people don't have strong community resilience because they're generally poor and they're not well prepared to deal with these hazards because they are more concerned about other social and economic issues like transportation, like infrastructure, housing, healthcare. So they don't really have sufficient resources to manage the risks of those hazards. So little is being done to address social economic factors of risks that make one group more vulnerable than another. What you do general risk assessment is that it helps you consider populations, or it considers populations to be homogeneous for risk planning purposes, and it thereby neglecting to address individual problems of certain social economic groups. So this is one of limitation of risk assessment, which may be improved on if you consider the vulnerability of various communities. The considering vulnerability of various communities may help to improve risk assessment and control this limitation. You have social advocacy groups have been working for years to raise awareness of the increased disaster vulnerability of special populations. Is something else. Another issue is special groups or special populations, which may include the disabled, may include the elderly, the poor, children, immigrants. All these people will be considered special groups for many reasons, because disabled may not be able to help themselves in the face of disaster. Similarly, the elderly people, as well as children. The poor people, sometimes they may not respond to disaster evacuation and other disaster protocols because of their poverty. Many of them are afraid of leaving behind all that they have because of their poverty. Immigrants as well, sometimes lack of communication, communication barriers, not understanding the local language or the language in which disaster information is being communicated might affect immigrants. Some immigrants also might be illegal immigrants, and because of that, this might also hinder disaster response efforts and recovery efforts. So these are some of the issues or risk factors that you may need to consider to help you to assess the vulnerability of the focus community and then use that to improve your risk management efforts. So we're going to see this is going to be the end of the lecture for natural and technological hazards, and as well as risk assessment of those hazards.